Today, I will introduce you to some formulas for calculating a derivative of a complex function. At first, let's just revise the definition of a derivative. The first formula to begin with is going to be a derivative of sum of two functions. To calculate this, we have to bring the given function to the form of the numerator in the definition of a derivative. Just like that, we're getting an equation for the change in the function's value. Now, according to the definition of a derivative, let's rewrite this as a limit and combine u's and v's. Now, using the property of a limit, we can separate these two equations, receiving a sum of two limits. And here we may notice that each of these limits corresponds to a derivative of u and v functions respectively. Just like that, we received an expression for a derivative of a sum, which is the sum of two derivatives. Actually, the derivative of a difference equals to the very same thing, but with a minus instead of the plus. The proof to that is analogous, so I'll leave it up to you as a small exercise. Now let's do the multiplication of two functions. Just like in the previous problem, we started with calculating the change in the function's value. And the main idea here is to add and subtract this following expression in order to group it and get the function change in the braces. Here, I will be marking those two expressions which we have to group by a blue line. Now, we are again using the property of a limit, that the limit of a sum equals to a sum of two limits. Keeping in mind the definition of a derivative and the fact that delta x in this case approaches 0, we receive that the derivative of multiplication equals to the following expression. Let's move on to something more complex, a derivative of a quotient. At first, we're just following the very same steps, getting this expression for a change in the function value. And again, the idea here is to add and subtract the same expression in order to get to the definition of a derivative after grouping. And one more time, using the property of a limit, we are getting our desired answer. Now, moving on to last, but actually the most significant one, the derivative of a chain. Now, the idea is actually slightly different. We have to multiply and divide our expression on the change of the internal function. And obviously, we have right to do so, since even though the change of the function approaches 0, it never actually turns into it. So now, let's group these expressions in a crosswise pattern. Once more, using the property of a limit, we get to the following. It's clear that the expression on the right here is just a derivative of v function. But if we think about this, the left side is a derivative of an external function u, since the change in its argument is actually a change in the function v. Just like that, we receive an expression for a derivative of a chain, which equals to a derivative of an external function multiplied by a derivative of an internal function. Now, let's try doing a couple of practice problems using the formulas we just obtained. As for the first one, let's differentiate the cosine of 2x plus 3. The first thing we gotta do here is to apply the chain rule. Let's write down the right side separately and examine its differentiation in more detail. Here, at first we have to apply the rule for the sum. The first element here obviously turns to 0, and in the end we end up with just 2, since a derivative of x equals to 1. And just like that, applying all the rules, we get to our answer. And now I guess this is gonna be it for today. And just as always, if you wish to get some additional problems, you may follow a link in the description or in the commentary section of this video. And you are listening to Copper. See you in a couple of days. Have a good one.